Hello students, welcome again to the new segment. In this segment we will be looking at some more advanced techniques and tricks with the KNN algorithm. So the first thing that you may want, we want to emphasize is that let's suppose you want to have a model with some subset of the features. That is, you do not want to have the entire feature set or the entire predictor variables to take part and build your model. So if that is your objective, then you can specify it while you are training your KNN classifier. So let's read some data first. So recall that we have already read the data into our system, and it has been stored in the C directory under the name 1. So 1.csv contains the RS data set. So once we have read this data set, we can now specify and use the fit CKNN function. And with that, the first argument we know is the table data structure. And then we want to specify that we do not want to use all the features or all the predictor variables. Rather, we want some subset of that. So the first thing you need to mention is the response variable, and then you need to include a tilde sign, and then you need to include the list of those variables which you want to include and build your model. So in this case, we want variable 1 and variable 3 to take part in building our model. So that's how you can mention that, variable 1 plus variable 3. If you want to include more, you can add more, right? So once we have done that, you may now notice some of the properties of M, and now it is saying that variable 1 and variable 3 is our predictor variables, right? So the other two variables, that is variable 2 and variable 4, it has not taken part in building our model. Let's suppose we want to build another model using all the features. Remember that we need to store it in a different variable, otherwise the previous value that is contained in M, the previous model, it will be lost. So we can use the same, right? And here with the response variable name, we just don't mention anything. So if we don't mention anything, it means that by default it is going to take all the available attributes. Now let's consider the resubstitution loss. Resubstitution loss for M, it is going to be 0.067, and with all the features, it is 0, right? So the evidence is clear. That is, when we add more information into our classification model, then we are going to have less training error, right? It is also evident from here. The other very important property that we want to emphasize is that the fit CKNN function, it cannot work with mixed type of data. That is the data that contains numerics as well as some categorical type. So in order to demonstrate this, let's again go to the UCI machine learning repository. And here in this repository, there is a data set called flag. So I will download that. So this is the flag data set. And now we may note that the attributes here are categorical as well as of integer type. So if we go to the data folder, we have the flags data here. So we may copy it and then store it within our computer in some useful place. And let's say I want to store it here in the C drive under the name 3. And then I save it. And then I change its name to, let's say, CSV, because I know that it is in CSV format. You can change its format to XLS or XLSX format. So now let's read it. And we call it T1 equals to read table. We need to specify the name, which in this case is 3CSV. And now it's going to read the data. Now that we have the data, let's have a look at some of the instances of this data to see what kind of data it is. So it contains the categorical data that is in letter form, right? And it contains some numerics, and it also contains some non-numeric data or categorical data, red, green, and so on. So now if we have this kind of data, and then if we want to use the fit-C-KNN function based on this data, let's say variable 1 is our predictor variable, sorry, the response variable. So in this case, you may note that it's going to return an error message. And that error message is that the predictors must not be a mixture of continuous and categorical data. So they must either be all numerics or all of categorical type. So let's do a quick example and change and delete these numerical data and just keep on only the categorical data, and then let's see if the KNN works. So if we go again here in this file, it will take some time because I have integrated the MATLAB with this Excel environment as well, so that's why it's taking some time. So let's delete this numerical data. And here we have some more numerical data. Right. And let's say this is the response variable. So I just want to delete this as well, or just make it empty. Right. And then let's say we add some numerical data to it. You may add anything, let's say A, B, A, and so on. And then we may extend it so that it covers all of our instances. Now we have created our own data set, and this data set contains only the categorical data. And this is the response variable, and it has only all the data belongs to a single class. Right? This is just for the sake of demonstration. This is not a real data set anymore. So let's close it and call it tree. So let's now read this data into the MATLAB environment. So let's say we say T1 equals to read table. And now we know that the file name is tree3.csv, so we will read it here. Now let's run the KNN classifier. Let's run that. So we know that now in this case the data is contained in T1 and the response variable name. So let's hold on for a second, because whenever we read the data, so the response variable name sometimes changes based on the data itself. So you need to pay a little bit attention to that. Now we may note that whenever we try to update a CSV file ourselves, so sometimes the response variable names may change, right, based on the first row of the corresponding file, right? So since we made some updation to it, that's why the variable names have been changed. So in order to use the correct variable names, we need to use the variable A as our response variable name, right? So when you press enter, you may note that now we have very interesting results. And the interesting part is that this distance metric has now been automatically updated to Hamming distance, right? So now it is not Euclidean anymore, because Euclidean distance does not work for the categorical data. The Hamming distance between two different rows is the number of attributes in which they differ. Right? So the Hamming distance only making sense in this case, so that's why it's by default considering the Hamming distance. If we change this distance metric to Euclidean for the same data, it is going to return an error message for us. Right? So we cannot do that. The Hamming distance, if you are not familiar with that, you can go ahead and grab some information regarding that. And I think it's quite easy. It's the number of attributes based on which two instances differ. So for instance, if we have this instance and this instance, so their Hamming distance will be 3 because they differ in all the 3 attributes. So that was one thing that I want to mention and clarify, that if your attribute is not numeric, so then make sure that all the attributes are categorical, and if they are categorical, then the Hamming distance is going to be calculated for the default distance matrix it's going to use is going to be the Hamming distance. So there were a few points. Hope you're enjoying the course. See you in the next segment.